All right, in section 5.7, we're talking about the Pythagorean theorem. This is for geometry, and the Pythagorean theorem is really actually pretty commonly known. I mean, it's one of those things that is something you touch on in a lot of different math classes, and so we are going to take a little bit more in-depth look. The Pythagorean theorem, it's one of those theorems. It's like it comes up all the time. Okay, so when we're talking about the Pythagorean theorem, we're talking about this. A squared plus b squared is equal to c squared. Well, these come from the sides of a right triangle. But they're specific sides. And what we're going to look at when I scroll down here a little bit is the actual sides that we're talking about and how they relate to one another. Okay, so I'm going to scroll down here a little bit, and if you've got the note guide from online, you can just move on down a little bit, and you're going to see two pictures here. And so what I'm going to do so we get the full effect is I'm just going to zoom out just a little bit so we can see everybody here right as we go. For years now, you have been taught that C is for cookie by Cookie Monster and Sesame Street. I'm not saying that was wrong. Cookie does start with a C, as you can see. But for our purposes, we are not going to use this any longer. C is not for cookie. C is for hypotenuse. Okay? So C is now for hypotenuse. And if you can see here, this guy standing in the middle here, this is Pythagoras. And it makes sense. It's his theorem. Or at least it's named for him. Actually, part of the deal is that this relationship between sides of a triangle was known many centuries before him, but he is the guy who it's named for. Okay, so C is no longer for cookie. C is for hypotenuse. Okay? And so this is how the sides relate in a right triangle. I've got a right triangle here, and C is going to be large C, so uppercase C, or capital C is going to be the right angle, and A is going to be opposite of A, and big B is going to be opposite of B. Okay, so that's how these things are related. Okay, Pythagoras wasn't the only guy to talk about this. In fact, he's not the only guy to prove it. And when we look at a proof of this, we have a picture here. This would be a good time to pause this and draw this picture. And what I'm going to show you is how these two things are related. We basically have a square, and we're going to be talking about the big square. Okay? And we are going to be looking at the area. Okay? And when we look at the area of the big square, what we are going to do is we're going to do a little bit of a proof that shows that the Pythagorean theorem is true. Okay? And so here, if we look at the area of the big square, the area of the big square is going to be side times side. Well, that's really equal to A plus B times A plus B, right? Because this side is A plus B, and this side is A plus B. Okay? And so I've just used the terms A and B because I know that each of these are a right triangle. Okay? And so it's all going to be based on these right triangles on the outside. Okay? And so the area of the big square is going to be A plus B squared, because that's A plus B times A plus B. This is just a proof that we're looking at right now. Okay? And so the area of the big square is also equal to the sum of all these things in here. So let's take a different look at it. That's the sum of the side times the side. But what if we broke this into elements? It would also be equal to the small square plus, so this in here, plus the area of the four right triangles. So all of that plus this, plus this, plus this, and plus this. Okay? So what would that look like? The area of the small square would be c squared plus, now, we need to know the area of a triangle. And so that's going to be base times height, a times b, divided by 2, or times 1/2, so 1/2, a times b, but we have 4 of them. So this is the triangle, this is the square, okay, times 4, because we have 4 triangles and we have 1 square. So it's going to be equal to c squared plus 4 times 1/2 a times b, which is c squared plus 4 times 1/2 would be 2ab. Now, let's look at what we've got. If we set these two areas equal, because really this is the area of the big square, and this is the area of the big square, let's set them equal. So a plus b squared, which is the area of the big square, is equal to c squared plus 2ab. Alright, so these are two different formulas for the area of the big square. We've set them equal. Now, let's expand this a little bit. We know that a plus b times a plus b is really equal to the foiling of all these things. So we have a squared, a times a, plus a times b, plus b times a, plus b squared. If we simplify this, this is a squared plus ab plus ab plus b squared. Okay, so I move this ba to be ab. A squared plus 2ab plus b squared, because there's 2 of these ab's. Now, a squared plus 2ab plus b squared is equal to c squared plus 2ab. Notice what I have here. I have a 2ab on both sides. So I'm going to subtract 2ab from both sides because I'm trying to balance it out. And what I'm left with is a squared plus b squared is equal to c squared. That's the Pythagorean theorem. So we use the square to prove the Pythagorean theorem. It's a beautiful thing. If that looks confusing to you, please write in the margin, let me know. I didn't understand where you got the area of the big square. I didn't understand why you did this second. I didn't understand why you did this step over here. Tell me specifically what you didn't get, or what you had questions about. Okay? And so all of this is just a proof of the Pythagorean theorem. There are hundreds of proofs of the Pythagorean theorem done by various presidents and scholars and students. Okay? And so if you have questions about this, let me know. All right, we're going to go down to example 1. If you've printed the packet out online, you'll have these right there. It says find the value of x, give your answer in simplest radical form. So what I'm going to do is I'm going to label these things because I know that c is always the right angle. So that makes this little c. I'll make this a and this b. It doesn't particularly matter because a and b are arbitrary, meaning that it doesn't matter if one of the legs is a and one of the legs is b, that's okay. Okay, and so this is going to be a because it's opposite of a. This is going to be b because it's opposite of b. So, find the value of x. A squared plus b squared is equal to c squared. So, a is 6, so 6 squared plus 4 squared is equal to x squared. I'm going to simplify. 36 plus 16 is equal to x squared. All right. And so I add those two things. I get 52 is equal to x squared. But I don't want x squared. I want x. And so what I'm going to do is I'll take the square root of both sides. So I'm left with x is equal to the square root of 52. if you remember from algebra, we are going to try to take a perfect square out. Well, I'm going to say that 4 comes out. So this is going to be the square root of 4 times 13 is equal to x. And that's going to be square root of 4 times square root of 13 is equal to x. Square root of 4 is 2 square root 13. And I know 13 is a prime number, so it doesn't have any other factors. And that's equal to x. You could have this. If you put this, it's okay. This one's a better answer. Okay? Okay, so just like we would in class, I'm going to give you time to solve this one on your own. And if you had questions on this one, write in the margin. Where did you get this? Where did you get square root of 52? How did you know that 4 came out of it? Okay, write those questions in the margin. Go ahead and pause here, try this next one on your own. Threw a little wrinkle in it for you, x minus 1, and I'm going to go ahead and solve it, but you can pause it here if you would like. Okay? I've still got a squared plus b squared is equal to c squared. So I'm going to label these a, b, and c. This is going to be a, this will be b, this will be c. So a squared plus b squared is equal to c squared. So 5 squared plus x minus 1 squared is equal to x squared. 5 squared plus, now off to the side here I'm going to expand this, x minus 1 times x minus 1. So I have front x squared, outside minus x, inside minus x, last plus 1. So I have x squared minus 2x plus 1. X squared minus 2x plus 1 is equal to x squared. And what I'm going to do is I'm going to go ahead and eliminate things that are the same, and so I'll use green to do that. So I'm going to subtract x squared from both sides because that gets rid of both of them. Gone, gone. So I have 5 squared minus 2x plus 1 is equal to 0. Now, I'm going to solve like I normally would. So I've got 25 plus 1 minus 2x is equal to 0. I'm going to try to get x by itself, so I have 26 minus 2x is equal to 0. I'll subtract 26 from both sides. Whoops, minus 26, minus 26. So minus 2x is equal to minus 26. I'll divide by negative 2 on both sides. X is equal to 13. Now, you'll notice, that doesn't give me the side lengths. Okay? That gives me just x equals 13. So this side is 13, and this side is 12. Notice, we had all whole numbers there, which leads me into my next point. A Pythagorean triple is a set of whole numbers a, b, c, so that a squared plus b squared is equal to c squared. What that means is no decimals, or radicals. Okay? Common examples of this would be, like in our last example, 12, 13, 5. Okay? We're going to list them in order. So common examples would be 5, 12, 13. 3, 4, 5 is a very, very common example used on standardized tests. 6, 8, 10 is a very common example. And also 7, 24, 25. Okay? So these are very common examples of Pythagorean triples. Okay? We can memorize those because that's going to help us. Now, when we do example 3, we're finding the missing side length. We're going to do the same thing. So I can label them A, B, C. So this is going to be C, this will be A, this will be B. And so I'm going to put this as A, this will be C, this will be B. A squared plus b squared is equal to c squared. So I will do 12 squared plus b squared is equal to 15 squared. 144 plus b squared is equal to 225. Okay. And when we do that, what we end up with is we subtract 144 from both sides. We get b squared is equal to 81. And so we are going to end up with the square root of this, square root of this. So b is going to be equal to 9. Okay? Now, you'll notice 5, 12, and 9 are all whole numbers. So when it asks if it's a Pythagorean triple, yes. It is a Pythagorean triple. 15, 12, 9 are all whole numbers. Okay? This is great news for us. Now, as part of your quiz tomorrow, I want you to solve this example on your own. I'll get you started. Here's the 90-degree angle here. And so when I label A, B, and C, I'm going to have this as A, this will be C, and this will be B. So we're going to use A squared plus B squared is equal to C squared. All right? So you're going to answer the question, is it a Pythagorean triple? All right? Thanks for watching, guys. We'll see you next time.